Hi Normada, I think you are new in this session, right?
Yes, sir. Yes.
Uh, from which course you are? MSc, BSc, or you are doing any job?
I'm doing my MSc second year polymer chemistry, sir.
From which university?
Madras University, sir.
Okay, okay, good. What is your next plan?
Sir,
What is your next plan? PhD job?
uh, clearing gate is next time, sir.
Okay, okay, good. Okay. Uh, Today we'll discuss about the three gate question from 2015 and 16. So first, you people try to solve this. If not, then we discuss this. Okay. Hi everyone. Now we're going to discuss one game. Okay, first read the question and try to predict the answer. Then we will solve. Any answer? Okay, tell me what is lithium LiNH2? Okay, someone saying option A. Any other option? Okay, any other option? Okay, then we get question from gate 2016, question number 24. The major product obtained in the following reaction is, so this is one substrate and we are treating with two equivalent of LiNH2 followed in liquid ammonia followed by C2H5Br one equivalent and followed by acidic workup. So in this four option you can see that in the first option this hydrogen is attached with this C2H5 moiety, and in another option this OH group is attached with this C2H5 moiety, and in another case you will observe that there is some kind of amine followed by amine and CH2 CH3. So we have to find out which option is correct. So for that we have to, our substrate is C triple bond C CH2 OH and H. Now we are treating with this with LiNH2, means we are treating with Li plus NH2 minus. That means we are treating with base. How many equivalent of base? Two equivalent of base. Okay. So that means there has in this substrate it has two acidic proton. This proton and this proton. We all know that OH proton should be more acidic than this acyclic proton. So in first this hydrogen will extract followed by this hydrogen. So first this hydrogen will extract, then this hydrogen. So it will form a dianion. Okay. So this will follow a dianion. This is this question, this concept is basically concept from the dianion. Okay, after that what will happen? Now it has two center, but we are treating with only one equivalent of C2H5Br. C2, what is C2H5Br? That means CH3 CH2Br. So what will happen? Normal SN2 reaction will happen. Now the question comes, which center it will attack? There is a carbon center and there is also oxygen center. So to know this answer, we have to again come to the soft and hard combination. So in the CH2 is the basically soft center, and among these two, this is soft center and this is hard center. So as we know that this soft interaction is good, so nucleophile must attack here, and one SN2 reaction will happen, and this bromine will leave. So what we'll get? We will get CH3, CH2, bond C, triple bond C, bond CH2, O minus. After this H3O plus, so this O minus will be protonated and we will get CH3, CH2, C, triple bond C, CH2, OH. Okay, so the our product will be this. So the thing is that here the main concept is the stops of interaction. Okay, and you can also explain that this center is more nucleophile than this center because this is carbon and this is oxygen, that is more electronegative. We can explain like this also. Okay, so the correct option will be option A. and B is not correct because that time oxygen is attacking here. And this type of amine is also not possible. This type of amine is also not possible. So our correct answer will be option A. So for more information, you can watch this NPTEL video. Thank you. Is it clear to everyone? Okay. If it is clear, then I am giving one question. Do this question first, then we'll go to the next. Tell me the product. The answer, the question is clear, right? CaCH2 be one equivalent. Okay, okay. Tell me the product. Let's take how many active hydrogen is there? There is two hydrogen. There is no active hydrogen, and here is also one hydrogen. Okay. So first lithium aluminum LiNH2. Which hydrogen will take? Let's take it is Ha and this is Hb. So which hydrogen will take first? A or B? Which hydrogen is more acidic? A type of hydrogen or B type of hydrogen? Any answer? A hydrogen is more acidic, or B hydrogen is more acidic, or which hydrogen will abstract fast? Let's say if A hydrogen is abstract, then it will form CH2 minus double bond O, and if B hydrogen will abstract, then what will form? See here one resonance is only possible, one type of electron delocalization is possible. Here two type of delocalization. It can go this side and it can go this side also. So it has more number of resonating structure than this. So this hydrogen, B hydrogen should be more acidic. So B hydrogen will abstract first. But we are using two equivalent of base. So now next time this hydrogen will abstract second time. First, second. Okay. So it will form again a dianion. CH2 minus C double bond O. Now we are using one equivalent of again CH3 CH2 Br. So tell me, this A center will attack or B center will attack? Which center will attack here? A center or B center? And on A center reaction will happen. So this is our substrate, and we are treating with three conditions: lithium NH2 2 equivalent, CH3 CH2 Br 1 equivalent, and H3O plus. So we are trying to say that in the first lithium ammonia regime 2 equivalent base, there is two type of proton that may be achieved, that is A type this proton or this proton. So the our first question comes, which photon will abstract first, A photon or B photon? If A photon will abstract first, that will form this. And if B photon abstracts, then it will form this. So between these two, this has more number of resonating star, more number of conjugation, because it can conjugate this ketone also and this ketone also. But this negative charge only conjugate with one ketone. That's why the B hydrogen will abstract first, followed by A. So after two hydrogen abstraction, it will form this intermediate, this dianion. Now tell me, after that SN2 reaction will happen, CH3 CH2Br, then which center will attack? A center the reaction will happen, or B center reaction will happen? Okay, tell me, where the negative charge is highly possible structure is there. I mean, in SN2 reaction, the nucleophile rate depends on the both nucleophile as well as substrate. So here nucleophile is this and this. Tell me, if the charge is high, then the SN2 reaction will be high. Now tell me where the chance of charge, this negative charge will be high. Either A center or B center. The possibility of negative charge will be high, because in the B center this negative charge is distributed with two ketone, and here it with only one ketone. So that's why the negative charge density will be high here. That's why the reaction will occur from this side, not from this side. So what we will get? CH3 CH2 CH2 C double bond O. After that, just protonation. Is it clear, or I should explain again? Okay, fine. Can you tell me how you confirm that the reaction is happening in this center, not this center? How will confirm? How will confirm that our reaction is happen in this center with A center, not with B center? How will confirm? UH. Okay. You can say that using NMR also, because if the reaction is happening here, then there will be only one H, and that should be in distillate position. But if reaction not happen, then it should be two hydrogen. Otherwise, it should be one hydrogen. That is one thing. And one another thing is that this time this CH2 will be singlet. Otherwise, this will show triplet-like structure. That is another thing. Okay. Now I'll go to the next. Hi everyone. Now we're going to discuss one GATE question from GATE 2016, question number 20. First read the question, then try to answer, then we'll solve. Okay, solve this. Right. The major product formed in the following reaction is, so this is our substrate, and we treat it with methyl iodide followed by sodium bicarbonate and methanol and heat. So we have to find out which option is correct. So in first option we observe that there is one methylation in the alpha 2 keto group, and in the second is the OAM formation of the OMe group, and in the third form in the C option there is the formation of a double bond, and option D there is the formation of the C2H5, and here is the CH3 moiety. So you have to find out which option is correct. So for that, we have to know the two things. One is the jet set product, and another is the Hoffman product. So in normal situation, let's say this molecule in this position, this is CH3, CH3H, and here the CH3. And if we treat it with silver oxide, that time one E2 elimination will happen. Okay. So now the question comes whether the reaction will happen. either this hydrogen will abstract or whether this hydrogen will abstract. That we have to find out actually. So if this hydrogen will abstract, that will form more substituted product. Okay, that is more substituted means always remember Z product. And if this hydrogen will form, just if this hydrogen will abstract by AgO minus, that means that time this product will form that is less substituted. That is called Hofmann product. So less substituted products means Hofmann product, more substituted product means Z product. So that we have to remind. Okay, we can draw this structure in this Newman structure. Okay, and we all know that for E2 illumination, the anti-peripheral geometry should be required. So anti-peripheral means the which hydrogen will abstract and which group will leave. That must should be 180-degree dihedral angle. So here see this hydrogen and this leaving group is 180-degree angle. So let's assume that in this case, this hydrogen is basically want to replace. So we can draw this transition state in Newman position like this. If we draw this transition state like this, we will observe that there is a Gauss interaction due to the CH3 and this NCH3 group. That's why this type of transition state will be disfavored. Whereas if we want to abstract the photon from this side and if we make the things like in this double bond with respect to this double bond, that time our transition state will be more stable and there is no such type of Gauss interaction. That's why it's a lower energy transition state and that's why and this is the high energy transition state. You all know that the reaction will go through a less energy transition state. That's why the reaction will happen here and the living group will go and we will get in this reaction this type of product. I mean less substituted product. Okay. So that is the thing. So in our reaction, so first what we have to do? We are treating with methyl iodide. That is called exhaustive methylation. So what will happen? It will form with N C2H5 whole 2 plus methyl group. So after that, what will happen? Basically, normal E2 elimination will happen. Here, no question of selectivity, that type of selectivity. So what happens? Just H will come bicarbonate, sodium plus NaHCO3 minus. So this will abstract this proton, and this will come, and this will go. So we'll get the product like okay. So our correct option will be option C. See this type of when it will possible when the hydrogen will abstract from here, but that type of possibility is also not here because we are heating up. Heating up means normally ET elimination will be preferred. Okay. And in option B, O any3, that is also not possible. That type of strong base is not using. Sodium bicarbonate is a mild base. That is also not possible. And option D, this is our intermediate, not the product. So our final option should be option C. So for more information, you can. Is it clear to everyone? Is it clear to everyone? Okay, I assume it is clear. So now we discuss one question from GATE 2015. Hi everyone. So first read the question. Reaction of benzaldehyde and paramethyl benzaldehyde under McMurray coupling condition titanium TiCl3 and lithium aluminum hydride gives a mixture of alkenes. The number of alkenes formed is, so first try the reaction. You know what is McMurray coupling? McMurray coupling is the reaction where the keto group is basically replaced just the reverse of ozonolysis. In the ozonolysis reaction, the double bond basically cleaves into corresponding keto group. So here two keto group will attach and we will get a alkene. Okay, then now we're going to discuss one gate question from gate 2015, question number 35. The reaction of benzaldehyde and paramethyl benzaldehyde under McMurray coupling condition TiCl3 and lithium aluminum hydride gives a mixture of alkenes. The number of alkenes formed is. So we have to find out how many different type of alkene is formed in the reaction with benzaldehyde and paramethyl benzaldehyde in McMurray coupling. So to know that, we have to first know what is McMurray coupling. McMurray coupling is basically the coupling between the two partner where the keto group is basically converted into the double bond. Yeah. And this is the bimolecular reaction. Here the two molecule basically added here. Okay, sometimes this type of reaction is also observed if we do carry out reaction at low temperature, and normally we get double bond. What happened here? The lithium aluminum hydride basically reduce the Ti plus 3 oxidation to 0 oxidation state. So the role of lithium aluminum oxide, lithium aluminum hydride is that it makes Ti3 plus 2 Ti0 state. So after that Ti0 will donate the electron here and this two double bond is basically like clip like this. After that, this radical will form and it will attach to the titanium, and then this type of high member cyclic ring will form. After that, the titanium oxide will form in the metal surface and you will get a double bond like this. So in our question we have benzaldehyde. This is benzaldehyde and paramethyl benzaldehyde. So what will happen? So let's say this is A, this is B. So how many different type of coupling is possible? A can couple with A, B can couple with B, and A can couple with B also. With these three type of combination is possible. Let's say this is R1, this whole part is R1, and this whole part is R2. Okay, let's see. So when AN means R1 CHO coupling, so it can form R1. So R1 can be like this, same side, or R1 can be in the different side, right? So that means it is two diastereomer is possible. One is cis and another is trans. Similarly, in the case of VV also there is also can cis and trans. Again, in the case of A1, there may be both group can be Z, I mean cis, or they can be trans. So how many number of alkenes is possible? So 1, 2, 3, 4, 5, 6. In the question they are asking about alkenes, not the alcohol. So 6 different types of alkene is possible. So to know more about this reaction, you can watch this NPTEL video. Thank you. Hi everyone. Now, okay, is there any query or any difficulties regarding this question? If not, then tell me how many product is possible in this possibility. Let's say we are taking three different type of R1, CHO, R2, CHO, and R3, CHO, and we are doing the McMurray coupling. How many product you will get? Take 5 minutes and tell me. So let's assume we are doing the McMurray coupling using these three substrate. So how many product is possible in the McMurray coupling? Take 3-4 minutes and tell me. Okay, let's say this is, so how many coupling is possible? In the two case, in the last case, six is possible. So here the coupling is with R1, R2, R2, and R3, right? And every time Cs and trans, right? So total self coupling will be six. Now consider R1, R2, R2, R3, and R3, R1, and again every time two. So again six. So self coupled product six and cross coupled product six. So total we'll get 12. Is it clear or not? Tell me if it's clear or not, otherwise I can explain again. So we are now taking this three type of substrate R1CHO, R2CHO, R3CHO, and we are doing the McMurray coupling. So how many type of alkene is possible? So for that we are taking, let's say, first time the R1 is coupled with R1, second time R2 is with R2, and third time R3 is R3. So every time C stands 2 possible is there. So again C stands, so 6. Okay. And second time, let's say R1, R2, R3, R2, R3, and R3, R1. Again, every time also 6 times, so 2 times. So total 6 into 6 plus 6, so total 12 possibilities there. Is it clear? Okay, I hope it is clear. Then thank you for joining. If there any question, tell me. Otherwise, we can finish this session now. Is there any question? Or I can explain anything, like if you want to know. Is there any question? And try also it for if there is four substitute, right? Try it home also. If four substitute is there, how many type of product is possible? Okay, then thank you for joining. কোথায় এসে গেছিস? কোথায়? ট্রেনে করে আসছিস? ঠিক আছে, ঠিক আছে। হুম।